February 22nd and March 28th.
Okay. So what do we think? We like the new room?
Yeah.
I like it.
Does the ceiling seem shorter to you?
It is shorter. This is drop ceiling. Yeah, this is new ceiling.
Do you know how much shorter it is?
I don't know. However, I'm guessing a couple feet, 2-3 feet.
Charles, we gotta measure.
All I know is it's expensive.
Measuring tape.
It's kind of ridiculous how much things cost. Like this thing right here. How much do you think this costs?
1,000.
500.
The whole setup.
Oh.
Oh, that's fine.
Huh? No, you can't say if you already know.
5,000.
5,000? 15,000?
That sounds horrible.
$30,000.
Oh, what?
$30,000.
Yeah, I was gonna say, I feel like you could build a table.
I mean, there's some equipment and stuff in here that looks expensive, but 30 grand? What? And eventually we're gonna have these tables all plugged in. These are all. Shut up!
Sorry.
By the way, I do that. So, these tables are all those. They have buttons on them once we get them plugged in, so they're those standing tables, so they can go all the way up. Oh, yours is plugged in. See, look at that. So you can stand and exercise. You have to agree with your neighbors.
Just like in the middle of an argument, just start going up.
Yeah.
It's like a platform on this.
Yeah, I think they're supposed to be like, so, you stand, it's better for your back, and you get some more exercise and stuff like that. So this is a standing table up here too, but I sit at it. Because, I don't know, standing seems like it's too much work. Right, Brocker? Mm-hmm. All right. Blackboard should open up this afternoon. I had so you know how I do all the Bible homeworks and stuff like that? So they're all up there already. If you wanted to get a start today, it's the book of Luke. There's 12 assignments, 2 chapters per week, but I put them all up at the front. So if you want to do them all, you can. It's the usual, read the 2 chapters, write a couple of sentences, how it reflects to your life, and that kind of stuff. I did reduce the percent of what that's worth to your grade. Too many people were writing Bible homework to passing grades when they sucked at everything else. So Bible homework's now worth 10% instead of the same as homework. Let's see. I'm going to make a pretty good guess at what the grade breakdown is real quick. So it's Bible/Tech Talks. This is 10%. Midterm, 15%. Final, 15%. Again, my usual policy, if you do better on the final exam than you did on the midterm, I'll replace your score in your midterm exam with your final exam. Not the other way around, though. So, if you get a 0 on this, you can still get an A in the class by doing much, 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 much better on this one. So let's see, what's 30, 40. So then homework is 60%. I might break homework into a couple of categories, drill and project, but they'll be like 30, so it comes out to the same thing. So that's the breakdown for the class. The usual thing with the homework, lots and lots and lots of assignments. You'll submit a assessment for each one. So, it's the assignments are your practice for the big game. And so I'll grade it with that in mind. So just because you don't get the right answer doesn't mean you won't get a pretty good grade on the homework as long as you put the effort in and things like that. Once again, strongly encourage you to form some study groups and post on Slack to kind of arrange when you're going to work on homework and that kind of stuff for your homework assignments. I'm not going to look for people copying and things like that. If you want to work as a team and turn in the same assignment, I'm fine with that. I'll find out on the exams whether you know what you're doing. So I'm not encouraging you to cheat and then hope for the best, but I get paid either way. So is the is the punchline. You're only hurting yourself. But I'll solve stuff in class as usual. Sometimes that's instructive for you. Sometimes it's easier for you to work with your peers and kind of go through similar types of hardships as you're solving the problem. So strongly encourage you to do that stuff. Questions on any of that? Go ahead.
I do not have the course on Blackboard.
Yeah, that's right. I started that thought, didn't finish that thought. So, you know how I put all the Bible homework and stuff up first? So I did that, and the first class I made was CSC300. And then I put all of their assignments in there, and then I copied the course over. So right now, the 300 course is a mixture of the 300 content plus the 200 content. So I just haven't had time today to go and to delete all the 200 stuff, and then I'll unlock the course. So it'll happen sometime this afternoon. It's fine. I was just wondering what that was. Yeah, so in any case, Blackboard will be up today. This is effectively what the syllabus will say, the usual stuff. I did also today post on Slack, as usual, every day, chapel, front row. You get 0 extra credit points, but you'll have my undying gratitude, something or other. But I also put up there, these are the dates for hackathons. These are going to be run by the Hackathon Club. So we have a mini hackathon that's 9 a.m. to 9 p.m. on February 22nd. So they'll break it into 8 teams of CS students. This is going to be Python, so this should be compatible with CSC300 students and above. Let's see, that one's in the computer science department. Then we're going to have a Batterman hacks, which is going to be over in the new building, March 28th to 29th, 8 a.m. to 8 a.m., so a 24-hour thing. So this one will be any technology goes, so that'll be our bigger hackathon. So both of those I'll be requiring in my classes, and there'll be alternative assignments if you are just unable to make them. But I strongly encourage you to save those dates on your calendar now. Ask off for work, whatever, blah, blah, blah. Those would be good learning experiences and that kind of stuff. One possibility might even be that if you have some study group in here and you want to work together as your team at the hackathon, we could probably make that happen. That kind of stuff. Out of curiosity, I know we had some people run study groups last semester. Who is planning on running another study group this semester? Okay, we have one, and we'll add you two together and say a half based on how high the arms went. Go into the 300 channel, wherever I put that, 300 channel, and post that you're going to run a study group, or if you're interested in a study group, that you're interested in a study group, and as soon as possible, try to get matched up for when people are going to meet, work on homework, things like that. I'd like to get as many people involved in that as possible. All right, questions about stuff? Go ahead.
Those hackathon dates are set in concrete, right?
Yes.
Okay.
At least according to Josh Appel, yes. And I pushed him on that. I said, before I advertise this, are these the definite dates? He said, details are to come, but those are the dates. So, anything else?
Do you, so you mentioned TED Talks?
Two tech talks this semester.
This semester?
Yeah, their dates are already up on Blackboard. I'm trying to think when they. Here, I can tell you. I'll go into 200. Actually, I can go into here. What am I on? Guest again? Yeah, I really sold that, didn't I? It's like, oh, just join the guest network. It's fine.
I told you it's much worse than that.
Or it's the excessive amount of tabs.
Oh, this is light for tabs for me.
This computer still runs fast even with all those tabs, so it's not bad.
Well, I have some decent hardware in this.
Yeah,
Load.
I'm just saying that that's not the only element. It's also the fact that
Well, that'll eventually finish loading, and then I can show you what the. All right, so 2:19, 6 p.m. to 8 p.m. And this is, I don't have the names up here yet, but this is going to be the CEO of a company called Aurora CDW. They're a data science, business analytics company that uses machine learning, artificial intelligence to help companies make business decisions. We have a pretty good relationship with them. They're out of Madison, but they have offices around the country, and they're about to open up an office in Milwaukee. And our own Eric Poole, who's a senior right now, is interning with them. And then Blaine Andrada and Eric are doing their senior project, separate projects with them. So that's going to be the CEO of that company giving that talk. And then the one on 4/7, so April 7th, 6 p.m. to 8 p.m., the usual location. Is her name Trisha? I think her name's Trisha Kane. It's possible I have her first name wrong. It might be like Tracy, but I think it's Trisha Kane. And she is a CTO of a company. She's been doing this for a lot of years. I don't remember the name of her company off the top of my head. She was going to be she was the canceled tech talk from last semester. So this there was a conflict with the Thanksgiving time and that kind of stuff. But in any case, she is a CTO, been in the industry for a long time, manages teams globally. So for those of you who are in the software engineering class this semester, this could be pretty interesting stuff because she's going to be kind of talking about the idea of, almost the level of abstraction above that, where, in software engineering, that's the first meeting is today with Dr. Locklear, right? Yeah. So that class, even though it sounds like a programming class, isn't actually a programming class. You'll do some programming in software engineering, but the class is about how do you manage relatively large projects with multiple people on a team and have those things come together in terms of a working final product. It's one thing when you have your homework assignment and you're controlling all aspects of it, but if you're reliant on a team of 5, 10, 100 developers, think about these big game companies or something like that, there's a certain science that goes into making all those things work together, and there's some different approaches to it, things you maybe heard of as like agile software development. Prior to that was waterfall. We had the guy from First Tech Talk last year, Mike Skygen. The Skygen guy from he was their director of software engineering, kind of talked about the weaknesses of waterfall and but effectively these guys are evolutions of each other, and how do we keep making it better. Acuity, a lot of you know that our best top graduates tend to have gone to Acuity more recently. They just moved over to Agile. In fact, they're kind of releasing it on a team-by-team basis, so I'm getting kind of interesting feedback from them as they, like one team's still waterfall, another team is doing Agile, and, kind of dealing with that new mentality of it. So that's what the software engineering class is about, is how do you plan and implement a large software project so you get to the point that the code almost writes itself. It's a paint by number in the end. In fact, you maybe heard me mention it before, that there's actually some really cool software engineering tools out there that if you put it in the right format and do enough detail for the project, it'll write large chunks of the code automatically. Just generate code that you can then build off of that with the project. So that's what that class is about. But she'll talk about maybe a level of abstraction above that where she is in charge of multiple global teams that are around, these are teams around the world that are each doing software projects and what challenges that has related to it. So those are the two tech talks this semester. I thought they were important to still have them, but didn't want to have as many of them. Okay, so those are the dates. These will be the exact same things that are on. Actually, they're already on your Blackboard, but I think they're duplicated on your Blackboard. And then there's some other things on there, is what it is. They make it too easy to copy courses and not easy enough to do other things that you should be able to do in Blackboard. What are you going to do? Okay, so one thing we're going to start doing for you, it's going to be in this class, but we're going to be doing it across the board starting in our early classes, is we're going to start heavily using Linux as our core operating system across all of our classes in computer science. So let's do a little, how many of you have heard of Linux before? What is Linux?
An operating system.
It's an operating system. All right, so that's OS. How many of you have used Linux before? 3.25 people have used Linux, okay. What operating systems are we most accustomed to using? Mac OS and Windows. Okay, so realistically, we would call those guys distributions. So Windows is a distribution. Does anybody know what the actual operating system that Windows runs on top of is called? Historically, it would have been DOS. Long time ago. Go ahead. Not Unix. The Mac OS, it actually runs on top of OpenBSD Unix. So the Unix kernel. Anybody know what Windows runs on top of? So Windows distribution runs on top of something called the NT kernel, New Technology Kernel. Historically, with Microsoft, you had DOS, and then we came out with Windows 3.1, Windows 95, Windows 98. Around the same time as Windows 95 came out, we had another operating system called Windows NT. It came out right before Windows 95 was NT 3.51, and about a year after Windows 95 was an operating system called NT4. And that shared the Windows 95, kind of the modern appearance to Windows. Windows today is heavily driven by the Windows 95 user interface. But Windows NT4 and Windows 95 were actually different operating systems. NT4 was running on top of the first rendition of second rendition of the NT kernel, whereas Windows 95 was running on top of DOS. As those two lines matured, you had really the NT line was the business line for Microsoft, and the DOS line was the consumer line. So if you wanted to play video games, you ran the consumer line. You wanted to do business and have the stability of the new NT kernel, but maybe not all the driver support for your graphics cards and things like that, you ran one of the NT systems. We got to Windows 95, which was good. Windows 98 was solid. Anybody know what operating system came after, what distribution came after Windows 98 on the consumer side? Go ahead.
Was it Windows XP?
You skipped one. Windows XP was the repair to this mistake.
Oh, yeah, that's right.
It's called Windows ME, Windows Millennium. So when Windows ME came out, Dell computers that shipped with Windows ME allowed you to upgrade back to Windows 98 if you wanted to. All right, so the idea being that it was bad. And so what came after that was a unification of the Windows operating systems. That is, they all now run off of Windows NT. So Windows XP was the first Windows distribution that ran off of the NT kernel for the consumer side, right? And then since then, we've had like Windows, now they're called like Windows Server, and Windows, we had XP, Windows 7, Windows 10, those are the consumer side, but they're all running off the NT kernel, and the distribution just has different stuff in them. At some point around, I don't know, mid-tier Windows 98 probably, DOS became known as the Windows 9X kernel. In any case, when you see this word kernel like that, you're usually talking about the actual operating system. All right, we're not going to get too deep into that in here. That's more of a 350 concept for what do operating systems do, blah, blah, blah. But that's the actual operating system, whereas the distribution is, and realistically, we call these things, we use the terms interchangeably, which is acceptable. But a distribution like Windows 10 or the Mac OS, we typically think of these as the OS, the kernel, plus all of the default supporting applications that we expect to be there in order to start being productive day one. A web browser, a text editor, probably some sort of image editor type thing, some other pre-installed stuff. Make sense? And different distributions might come with different stuff. Certainly if you buy a brand computer like HP or something like that, they put extra stuff into their distribution, right? You have a whole bunch of these pre-installed applications that are supposed to make your life better and, whatever. All right, so we have a Windows distribution is based on top of the NT kernel. Currently, Mac OS distribution is built on top of OpenBSD Unix, which is a closed source Unix kernel that came out of University of California, Berkeley, many, many, many years ago. And then we have something called the Linux kernel. The Linux kernel is the actual operating system. Now we have many, 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 many distributions of the Linux kernel. So those of you who have used Linux before, what distributions have we used? Or can you name some popular Linux distributions? We'll only throw like 2 or 3 out there maybe. Ubuntu? Okay, so we would probably say Ubuntu. I think I'm spelling it right. Is it, maybe this first N isn't there. Is it just Ubuntu? Ubuntu? Let's go with that. All right. UB?
Yeah, no, and for the.
Like that?
Yep.
Okay. I would say Ubuntu is probably among the most popular distributions of Linux today because it's attempted to meet users where they are. So if you're currently a Windows or a Mac user, Ubuntu is probably going to feel the most comfortable to you starting off day one because it has a lot of tools built into it that makes Linux not necessarily feel as intimidating. Something like that. But it's still based on top of the core Linux kernel. Any other distributions you know of? So for those of you who've worked with Raspberry Pis before, Raspbian, which is actually based on top of a distribution called Debian.
Yep.
So it's a distribution on top of a distribution. So Raspbian is effectively a distribution that attempts to remove a lot of the extra fluff so it runs on a little bit lower powered hardware. Go ahead.
How slow does that make that for it to be on top of it?
Well, when we're talking about distributions, we're really just talking about extra pre-installed software. Yeah, but Debian or Raspbian specifically is working with a kind of a cut down version of the Linux kernel. They removed all the extra fluff from it so that it basically works well on a Raspberry Pi and it doesn't really pay attention to other machines because it's built really for the Raspberry Pi.
Yeah, if you want your Raspberry Pi to run slower, use the guest Wi-Fi network.
Oh, extra bad?
Yeah, we had to use that for IT. It was not fun trying to do projects with it. It's terrible. It's torture.
So I'll throw a couple of other things out here. So Slackware, Fedora, Some of you maybe have heard of Red Hat Linux. So Red Hat and Fedora, you could almost look at this as like this is their Windows NT. This is their consumer line. So in the early days, Red Hat was probably one of the more popular Linux distributions. Then they went public, and their Red Hat Enterprise product ended up being something they put into like server systems in Enterprise and things like that. And then they released a consumer-centric OS called Fedora. Get it? Fedora is a type of hat. Red Hat, Fedora. All right, so in the early days, it was called Red Hat Fedora, and now they just call it Fedora. But in any case, all of these are distributions of Linux. They're all running on top of the Linux kernel, the same core operating system, just a different starting point. There's also versions of Linux you can just build from source code yourself and then just make your own distribution. Choose which X window, you get Windows, normal Windows, you're stuck with the Windows user interface. You get Mac, you're stuck with the Mac user interface. There's some hacks out there that allows you to do some other stuff, but with Linux, if you go with a normal distribution, they're going to have a default X windowing interface, but you can switch that up. But if you build your own, you choose what X windowing interface you might want. We're going to spend a lot of time in here working from the terminal anyways, so this allows us to roll back in time and think about, well, what about computers that didn't even have a graphic user interface? That we would just be sitting there at effectively something that looks like a DOS prompt. Okay? So we're going to be starting to use Linux. What do you think the rationale for that is? Go ahead.
Well, Linux is a lot of third-party stuff, and it's usually open source, which means that we can work with the code more.
Okay, reasonable enough assumption.
It's kind of like driving a manual car versus driving an automatic car. So
Okay.
more of the behind-the-scenes stuff.
I think there's truth to that, especially since we're going to be starting this from a position of being ignorant of the Linux ways of doing things. We'll see some connections there, though. It's going to feel a little bit more like we're using the operating system as opposed to the operating system being overly convenient to us. What else?
I was about to say, kind of how I see it is like you're really fully utilizing the tools on your computer versus like having more of a bogged down graphical interface. You can use the command line to really do things that you want with your hardware.
I agree with that, and let me actually just flip that and give you the other side of that same coin. And it's really where my mentality of this is if you walk down the hall to a nursing student, they're going to be comfortable using Mac OS or using Windows, right? You walk down the hall to a business student, somebody else. In their professions, they don't necessarily have to have this great expertise in multiple operating systems. In business, if you only had to pick a single OS today, you probably would pick Windows, right? I know Macs are becoming more and more popular, especially with laptops, but in the business world, Windows is what the places are using, okay? So if you could only pick one, you'd probably pick Windows. Mac users are also typically used to Windows, at least could get around. I would say it's easier. What I always have found interesting is that Mac users will usually talk about how great the user interface is and things like that. My experience is if you put somebody in front of a Mac and you put somebody in front of a Windows machine, they'll be able to figure things out more quickly on a Windows machine than on a Mac. Because the Windows machine has a button that says start, or at least something that looks like a button you click, right? You go to a Mac, where do you start? I've loaded a bunch of crap down here, clicky stuff, but ultimately you have to know where to go and find your applications folder and things like that. I'm not sure that the Mac user interface is all that amazing personally, but whatever. Get used to it, because from a Linux perspective, you have a much more, although Raspbian and Ubuntu both have effectively start menus. But in any case, we're computer scientists. We should have a fluency of multiple operating systems, and especially when we go into industry, whether we're on the IT side of things or we're on the computer science side of things, pretty good chance that wherever you're working, they're going to be running Unix or Linux servers somewhere, and you're going to be deploying your software to Unix-based systems, and having familiarity with those systems is going to be a requirement, or at least an advantage for your job. And there isn't a great reason as computer scientists that we shouldn't have a higher expertise in operating systems than the average profession, right? That makes sense? All right, so we're going to start using Linux in most of our classes. We're starting to hand out Raspberry Pis in 175, and we're actually going to use them throughout multiple classes. I'm going to, in my classes, primarily work with virtual machines. So let me talk about that. How many of you have ever worked with a virtual machine? Okay, what is a virtual machine?
You just log on to a machine on a server.
Okay, so that would be a machine somewhere else that's running, so I can remote into a machine. Go ahead.
Well, last semester when we were working with the Android application designer thing, with the phones that we would download to run the apps.
Yep.
The virtual machines.
Yeah, so we were virtualizing the Android operating system on our on Mac or on Windows.
Will the Macs running Windows be considered like a virtual machine?
So our Macs in the lab, those guys are dual booting Windows. So you have the core set of hardware. So if I'll just draw a picture here. So let's just call it Intel-based hardware. So all those Macs in there are running Intel processors with, some RAM and a hard drive and blah, 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 right? And then on top of that, we have Mac OS, and we also have Windows. So you dual boot into these. So when you first start up the computer, you pick which of these operating systems you want to run, and they're running locally on the hardware, directly on top of the hardware. So this would not be a virtual machine, this would be a machine. Go ahead.
So since Windows is running on top of an NT kernel, is Windows technically a virtual machine since it's running on top of something?
No, but now we're getting closer. So Windows would be a distribution, but now we're getting closer to what's going on here.
So you basically run your standard based operating system on your hardware, and on top of that, you run the virtual machine. Is that how it kind of works?
Yep. So, for instance, on my computer right here, let me launch it here. So, I'll just hit play on this guy. So I'm running Mac OS right now, correct? There's Windows. Here's Mac OS. There's Windows. So Windows is running as a application in Mac OS. All right? So what do we have here? Sitting in the middle, you're going to have a virtual machine. So a VM. Oh, and these guys have some funny, cool names associated with it. So sometimes these are called hypervisors. All right, so common hypervisors for computers. For Mac, we have something called parallels. We have VMware. Just leave it at VMware there. Mac has a product called VMware Fusion. VMware runs on Windows. Both of these cost something. we have something called VirtualBox, which is what I'm going to recommend for those of you in here because it's free. All right, so think of these as software applications that will run on top of your operating system. Parallels runs on Mac, VMware runs on both, VirtualBox runs on both. So we would call this guy down here our host OS. All right, so that's whatever operating system we are running natively on our computer. I'm running Mac OS, he's running Windows, so most of us are running one of those two. If you're running Linux, you can also run VirtualBox on top of Linux. All right, so you have your host OS, then you install a software application on there, one of these, some virtual machine. And what a virtual machine does is it virtualizes a machine, i.e. pretends to be a standard computer but managed through software. All right, so let me show you an example of this. So if I bring up the specs of my computer here. So I have an 8-core Intel i9 processor in here, and that has hyper-threading, so that's actually 16 cores. So I have 16 processors. I have 64 gigs of RAM. Now, do I need 16 processors or 64 gigs of RAM in one computer? Obviously, you need that in your toaster. All right. So what do you do with this type of stuff? I have a lot of resources. I have hardware resources that can be put to different things. All right. So now what if I had one processor and 4 gigs of RAM? That would be a significantly different classification of computer, right? Okay. You can't even buy a one processor computer anymore. Let's just say it's a dual core computer, dual core processor, but 4 gigs of RAM. If I'm going to run a host operating system, that guy's already taking up some of my resources, right? If you're running Windows, anything below probably 8 gigs of RAM, Windows is going to feel a little sluggish. If you're running Windows 10, Windows 7 can run on less, but Windows 10, probably 8 gigs of RAM is your minimum for feeling like your machine is fast. 4 gigs would probably work. Then it's also using your processors. So your host operating system is going to demand some of the resources of your computer. That's the point, right? We have an operating system that sits on top of our hardware to make that hardware easy for us to manipulate, for us to leverage. All right? So our host operating system is using up some of my system resources, some of my processing power, some of my RAM. Now, is it likely that I have extra processing power and extra RAM left over after the Mac OS has finished launching and I've run my 4 zillion tabs and all that stuff? Yeah, I have extra resources on this machine. So what do I do with those extra resources? I can create multiple virtual machines and associate some of those resources to those. So for instance, I can create, let's just look at what I have done here. So let's look at Windows 10 for hardware. Oh, can I not see how much RAM and stuff I gave it yet? Let's see. So I gave it, nope, can't see it there either. Well, here, I'm just going to pause my virtual machine. So when I pause it, that's going to, any resources it had grabbed from my machine, it's going to relinquish those because it's no longer using those. All right. Let's see if these things can pop back up now. If not, I'm not going to worry about it too much. Oh, here we go. CPU memory. So, all right. So when Windows is running, I'm giving it 8 processors and 16 gigs of RAM. So that means I'm taking away 8 processors from my computer, and I'm taking away 16 gigs of RAM. Mac's not allowed to use those. Now, most virtual machines kind of allow some sharing to make it optimized a little bit, but for the sake of for the sake of our talk here, let's just assume that I'm giving away those resources. My Mac does not have access to 8 of its processors and 16 gigs of its RAM. Instead, it's setting those aside and building a computer out of software that runs on top of that hardware. And what am I doing? I am running Windows on top of that virtual machine, which is running as an application in Mac OS. That make sense? So this guy provides a virtual machine, and then I can install an operating system on a virtual machine, just like you can install an operating system on a machine, a computer. That make sense? All right, so this is a nice, convenient way for you to run other operating systems within your current operating system, with the trade-off that you are sharing your system resources. Make sense? So with that in mind, the beefier computer you have, the more you'll be able to do this at the same time. Linux will run with less system resources than Windows or Mac. That's what it ultimately comes down to. So you can probably run Linux with about 2 gigs of RAM and 1 processor would get you by, especially if you use one of the lighter weight Linux distributions like Raspbian. But in any case, that's the idea of a virtual machine. So for many of you, for what we do in class here, I would suggest you go to VirtualBox, and I'll put a link up to this on Blackboard. Download VirtualBox. VirtualBox will give you your virtual machine. Then you'll go and you'll download a Linux ISO. So whether it's Ubuntu or Raspbian, I'll give you a couple of choices. Doesn't matter. All of those are running the Linux operating system with a distribution sitting on top of it, giving you some starter applications, things like that. Okay? And then we'll install things as we need them, but a lot of the stuff we're going to need in here is already installed on any distribution, because we're going to be doing C++ stuff in here, and we're going to use the GNU compilers, which can compile C++, and that's part of all Linux distributions, day one. All right, so if you have a text editor, which all of them come with, and you have the G++ compiler, off to the races. All right, you might want to install a nicer text editor to allow you to write code in a little friendlier environment, that kind of stuff. But at the end of the day, you can just run it in there. Okay, so that's what I would recommend for most of you. If some of you have run virtual machines before, you might have a license to VMware or a license to Parallels, which are nicer, more optimized solutions that cost money. If you have access to that, I would recommend one of those. But VirtualBox is very, very, very common. I'll put up a video on how to install Ubuntu on VirtualBox. I might recommend Ubuntu if you have enough system resources on your computer to run that, mainly because it's a fairly new Linux distribution relative to, Linux has been around for years and years and years and years. And you'll find lots and lots of examples of things when you're trying to I want to do this. I need to install application XYZ. You'll find lots of tutorials and things like that for Ubuntu online where you'll have to translate those for other distributions in any case. But Linux is Linux at the end of the day. Okay, so questions about virtual machines? Go ahead.
Ubuntu is the host OS, or the Mac OS in this example?
No. Ubuntu would be this guy up here.
Oh, okay.
You're going to want this. I mean, if you want to just switch your host OS to Linux, then you don't need to run a virtual machine. You can just say, I'm a Linux user now,
Yeah.
and that's fine. If you have a laptop that doesn't have a whole lot of extra resources, you might then choose to dual boot your computer. So this would be a virtual machine setup. Alternatively, you could skip the virtual machine thing and install Linux on your computer, and when it first boots up, it'll ask you, do you want to boot into Windows or Ubuntu or Mac or Ubuntu?
Kind of like the systems that we have
In the lab.
Yeah, the lab.
Yep. So you choose.
Yeah.
In this case, Ubuntu would get 100% access to your hardware, but you would not be able to use Mac OS while it's running or Windows while it's running. In this case over here, Ubuntu is getting some subset of your hardware that you give it,
Right.
but it's running as an application inside of Mac OS.
Yeah, now I got it.
Is there any like cons to having a dual boot system? Like any issues that can arise from having something like that?
I would say the only thing is inconvenience. You know, if you have some applications that you are commonly using your email and stuff like that. Yeah, I mean, if you want to, you can put your email on both, right? Get an email client for Linux, and you know, when you're in Linux, you check your email with Linux. When you're in Windows, you check your email with Windows. But if you want to do Windows stuff and you're dual booting, you'd have to restart the computer. Not the end of the world, but a thing, right? So you get to decide what you want to do. Now, I don't know when this is going to be up and running. We're starting to work on it Wednesday at 4:30 this week. We got 3 pretty beefy computers. So they are, each of them is 24 core with 128 gigs of RAM. And we have 3 of those that we're going to put together running a VMware server to host virtual machines. And then it would end up being more like he suggested, where we would actually run a virtual machine in another computer and you would remote into that and use the virtual machine.
I did that at work.
Yeah. So if any of you are interested in how that works and how you set that up, we're going to be we have a former student, Bobby Eberhardt, coming in, who works in that industry, works for Skygen actually. And he's going to help us start setting it up at 4:30 on Thursday. 4:30 Wednesday, tomorrow. 4:30 tomorrow, somewhere here in CS. We'll start setting it up. I don't know how many days it's going to take to set it up, but if you want to learn about that stuff, feel free to show up and learn about that. I'm not sure when we'll be able to host those, hopefully sooner rather than later. I just don't want to promise you will have an access to your own Ubuntu virtual machine next Tuesday. We might have issues, who knows? All right, but that's the ultimate goal, is that we would be able to, if we needed a 60-person lab with a certain version of Linux with certain things installed on it, we can create an image, spin up 60 copies of that, and now you have 60 people using that virtual machine without using any of their system resources. They just remote into it and are using it. They're at the mercy of the network, right? So hopefully, even if you're on guest, it's a local network, so you're not dealing with internet connectivity, but who knows? Might still suck. I don't know. We'll have to experiment with that. But in any case, that's something else that we're going to be doing this semester, to have some more flexibility on the operating systems that we can use for various projects in classes and stuff like that. But for right now, we're going to call these your 2 options. All right. I guess a third option would be I can get you a Raspberry Pi, and you can just run Linux on the Raspberry Pi and remote into it or hook it up with a keyboard and mouse setup, and you'd be able to do it that way as well. All right, so these are going to be the more convenient options versus having this extra little computer you have to plug in and stuff like that. But if your preference is, hey, my laptop sucks and I'm not going to be able to make that work, then we have that as an option as well. So I need everybody to have access to Linux one way or another. It's the punchline. Cool? All right, so questions about any of that and the virtual machine stuff? All right, so for example, in here, whenever, so if I'm in my 200 class, for instance, I'm going to be running Raspbian. So this is the Linux operating system that runs on the Raspberry Pi with Python. The reason I'm doing this is a lot of those students are also in 175, where Dr. Wall is going to be handing out quad-core Raspberry Pis and doing stuff with Linux and Raspbian and stuff like that, so they have an interface they're used to working with. All right, so that's why I'm using this guy with that. In here, I'll be using Ubuntu as our core OS. I think it's a better distribution. I'm also using this in the 450 class. Now, what's interesting right now is I have Raspbian running, I have Ubuntu running, and I have macOS running. All on one computer. More resources, the more you can split that across. And that's effectively, we're doing that on steroids with that 3-machine setup that I talked about, where we have a lot of RAM and a lot of CPUs that we can spin up a certain number of machines, as long as they're not, I mean, we're going to be able to spin up less number of Windows 10 computers than we would be able to spin up Linux computers on that hardware, because it doesn't go as far with Windows. Windows requires more RAM and that kind of stuff. All right. So let me put Raspbian to sleep, leave Ubuntu up. So now I reclaim those resources. All right, so we're going to be using that in this class. So what I want to start off with here is we're going to go over here to Ubuntu. It's going to look kind of like this. Notice you sort of have this little startup thing down here where you can search for stuff. It comes with Firefox as the installed browser. If you want a text editor, just do a search for like text. Something like that. There's your text editor. I do a lot of stuff from command line, which is okay. I don't remember if I installed Atom on here. But whatever, there's some other text editors that we can use. But what I'm going to start off with here today, what you might want to do, we're going to do a lot of command line stuff. So you search for terminal. And once you open terminal, I think you can right click on that and say add to favorites. And that will put terminal over here so you can quickly get to it. So terminal is a application we'll use pretty often, and I'm actually interested. Do we have Javik on here? We do. Oh, we don't. All right, so that's okay. So notice here, I said I wanted to run the Java compiler. Java compiler was not installed by default on here. But look at this, it gives me some options of what I can do. All right, so we have the default Java development kit. We have an open source version of that. I'm going to use this top one here. All right, so let's talk about what this does. So sudo says do this as super user. This is equivalent on Windows as run as administrator. All right, then we have a tool called apt. You can also say apt-get. And apt is a package manager. And what do I want to do with that package manager? I want to install something. What do I want to install? I want to install the application that is the default JDK. So as the super user, I want to use my package manager to install the default JDK. There's also a graphical installer, but why would, cool kids don't do that. So we'll do it from the terminal here. Wants to know my password for the super user. Put that in. It says, in order for the JDK to be installed, I need to install this extra crap to make it work. But that's not my problem. That's what the package manager does for me. If we roll back the clock and look at this years ago, you would have had to go and download each of those individual things and manually compile each one and stuff like that. This is equivalent of double-clicking on a setup.exe file on Windows. Except this will install all of the required applications, where sometimes with Windows, it'll say, oh, I couldn't find this, and you have to go and download it yourself. All right, so I hit Y for this. It's going to download all the stuff, and when all this is said and done, I will have the Linux compiler installed on, or the Java compiler installed on Linux here. All right, and we're only going to use that a little bit because what I'm going to do here is we're going to spend some time looking at the conversion between Java and C++ in the first couple of classes here. Okay, so I'm going to roll back over here real quick, and we're going to remind ourselves of something from 200. How do human beings solve problems? What are the three things? Memory, ask questions, and repetition. All right, remember those? 100% of programming languages have facilities for those three guys. You've heard me say that before? Okay, so usually we call this guy the mapping. 100% of programming languages have facilities for memory, usually through something called variables. For asking questions, usually through conditionals, or we might say if statements for any C-based language. And then repetition is going to be loops, functions, procedures, subroutines, pick your poison. All right. So 100% of programming languages will have facilities for these three things. So if you can learn how to do these three things in any of those languages, in any brand new language, you can already start using that language day one. All right. Now, actually, let me do this picture real quick. So we think about our language lineage that we're kind of working with here in our native languages. We had a top-level language called C. Off of C, we have a language called C++, which we're going to be using in here. Off of C++, we had a language called Java, which we used last semester. Off of Java, about halfway through, due to a lawsuit we talked about at the beginning of class, we have a language called C#. Microsoft tried to steal Java, got sued, came out with C#. It's okay. I mean, C# pushed the industry ahead because C# brought some stuff to the table that Java did not, and Java has now added it to make Java higher performance than it was before. Remember, Java is slower. It's a compiled language, but it's slower because it runs in a virtual machine, right? So there is a fake computer. What kind of computer? A computer capable of running Java programs called the JVM, the Java Virtual Machine, that runs on top of your host operating system that runs your Java applications. So you have this translator there in the middle, and that's why Java is inherently slower than a native language like C++. C# says it's a .NET language. It's platform independent on any platform that's running the .NET component architecture, which is effectively saying the ha-ha joke of that is C# will run on any platform at all, as long as it's Windows. All right. Whose fan is going crazy? All right, so.
I can control mine and his one off, so I went.
Oh, is he installing VirtualBox?
Yeah.
So in any case, C#, what it does is the first time you run the application, it compiles it using the .NET component architecture, and ultimately your application is then a native application that runs right on the hardware. So only the very first time you run a .NET application will it start up a little slower. After that, it's a native application. It's not running through a virtual machine. So you're going to see more and more video games and things like that written in C#, where historically they've been written in C and C++, which are compiled natively for your hardware. Java's not there yet. Java still runs inside of a virtual machine. I don't think it's going to be able to escape that. Now, that has a lot of advantages. If something's running inside of a virtual machine, if something bad happens inside of that software pod, let's say your virtual machine gets a virus. What do? Replace the virtual machine. So what you'll have is a lot of companies anymore are actually running their ecosystems inside of virtual machines. So what you'll do is you'll have a computer, you'll remote into a virtual machine server, or you'll run a virtual machine locally on your computer, whatever it is, and they'll have a template for this is what all employees at this company have on their computer. This is what's installed. This is whatever it is. So all of a sudden, you open up a bad email on your computer. You have a virus. Well, you have two options. Somebody can come in and install, the virus removal tools and try to remove malware and all that stuff, malware bytes and all that junk. Or they could just spin up a new virtual machine for you and say, here's a fresh computer. In 5 minutes, go back to work. All your files are stored on network drives and things like that, segregated from the operating system itself. You haven't lost a beat. That make sense? Except maybe your desktop wallpaper or something like that you tried to set. You got to put your Hawaiian sunset back on there after, you're during the winter time here in Wisconsin. Yeah, that was all. So most of you know I go on like these big long cruises, especially over winter. Well, I found myself, I was on this super long cruise over Christmas, and I actually, this is like something you see from a movie, it's like, whose life is like that? Every day I would get up and I write software on my cruises because I'm messed up. It's my hobby, not just my job. But I'm sitting at the wine bar, writing software, and I did not know what tropical island we were parked at. I had no idea I roughly knew where in the world I was. And that happened multiple days in a row. Because I would never look at the itinerary because we don't get off the ship. But we were it turned out to be Aruba. Isn't that bad? You don't know where you are. It's like a joke. My mom texts me and she says, "Oh, where are you today?" I said, "I don't know, but here's my view."
Try to find the MG.
I woke up, I don't know where the hell I am, Mom.
Seriously.
That's a good thing, though. It's a good way to know that you are relaxed and on vacation.
Yeah?
Yeah, I mean,
Yeah.
that's how I felt. I remember growing up in the summer, you wake up, you're like, I don't even know what day of the week it is.
That's another thing. You don't know what day of the week it is when you're on a cruise. Everything's handled for you. In fact, how many of you have ever been on a cruise before? 1.5 of you? A lot of the cruise lines now, when you get in the elevator, they have a plate in the floor that they change each day to tell you what day of the week it is. Yeah, you're just checked out from life. Except now they have good internet on them.
Thank goodness.
But I actually had a similar thing with my parents are on like a 65-day cruise right now. And I asked my mom where they were the other day, and she said Peru. And they're going like down through the Panama Canal and all around, but they go through the Panama Canal twice because I think it's a repositioning from like Florida to California, and they go down through South America. So I think they kind of make a big figure 8. That way they go through the Panama Canal at least once. They have to go through it twice. She said she was in Peru, and she wasn't. She was on the wrong side of South America to be in Peru at that moment. So we looked up and we found out where their itinerary was. I don't know, maybe it was Ecuador or something like that. But yeah, she didn't know where in the world she was either. But that's not really uncommon for my mom. So that's more of an old people problem. And she would agree with me. So, okay. So in any case, this is the world we've lived in up to this point, right? So and then if I throw in our one extra guy from 200, we had this dude over here, Python, right? All right, and Python's one of our interpreted languages instead of a native language, so we usually put it over in this left column, but still a programming language, still came off of C as the kind of the main line. But we've worked with Python, we've worked with Java. Some of you have worked with C#. You will be working with C# this semester in software engineering, but not necessarily learning C#. You'll be using that as your tool because you're learning software engineering skills. You just happen to, you'll be using visualstudio.net. But in any case, you'll get exposed to this. You'll see that C# and Java are effectively the same language. Like if you write hello world in Java, you have to change like 2 things to make it work in C#. Like instead of a lowercase or a capital S for string, it's a lowercase s for string. In fact, I think current versions of C# will actually map an uppercase string to a lowercase string, so you can actually use the uppercase string. The languages are extremely similar, all right, for good reason. We're going to back up in here 1 level to C++. Now remember, when we talked about Java in 200, when we talked kind of about the evolution of languages, we said that one of the things Java did was it removed some syntax that made, syntax from C++ that made programmers write extra code that always had to be the same. So effectively, whenever you have something in a program that 100% of the time you would write the identical code, our more modern languages tend to take out that extra letters you have to type, extra symbols you have to type, and say, here is the shortened version of that. We'll write the extra piece for you. It eventually gets to the point, though, where you almost remove too much, and it's no longer a language. Too much is assumed, and one of the problems learning a language like Java, one of the problems learning a language like Java first is you aren't exposed to that older stuff. But one of the benefits of learning a language like Java first is you can focus on programming as a skill set rather than on all these little idiosyncrasies. That makes sense? Can kind of go either way. I tend to go a little bit backwards. So we start off with something that is quite evolved, then jump into something that's a little bit older. We'll call these guys the same. And now we're rolling back to something that's even older. And when you get into the 450 class, we work in C, which most of our modern operating systems are written in. Okay, so in our 450 class, we're writing an operating system. In fact, we wrote our first operating system yesterday in class. So in 2 hours, we wrote a highly useful operating system that doesn't do anything. It technically boots and puts 1 value into a hardware register. Okay, so what we want to start off doing in here, let's see where we're at over here. All right, so I should have JavaC now. Haha, I do. All right, so if I want to write a quick Java program, so I'll say vi hello.java. Actually, let me. All right, so I'll open up a text editor. So I'm actually running this completely from a command line. This could be, you could be remoted into a machine using SSH or Telnet or something and, not have any sort of graphical window system. I'll put another text editor on here so it looks a little friendlier, but for right now, this will work. All right, VI is the text editor you've been training your whole life for. It's made for touch typists, so if I want to save a file, you go into command line mode and do WQ right quit, and you've saved the file. By default, you're in stock mode. If I want to go and type something, I press I for insert. Ninja. What have I done? There, now I'm in insert mode. All right, so I'll say public class hello. What did I name my file? Lowercase. And to delete, of course, you go to the beginning of the line and hit X to delete. Oh, don't backspace while you're still in insert mode. All right, so public class hello, public static void main, string array args. And we'll do our system.out.println hello world. All right, so there's my error-free hello world program. I'll save that. So there's my file hello.java. If I want to compile that, I'll use the Java compiler, javac. And hello.java, press enter, no errors. I have this hello.class file now. And I'm going to run that using the Java virtual machine. So I say Java, hello, press enter, and there's my hello world. Make sense? All right, so what I want you to do for Thursday is get virtual machine installed. Well, one way or another, get Linux installed in your computer and get a Java compiler installed. You can, if you use Ubuntu, you can just follow the identical instructions I did today. Actually, most versions of Linux, you can probably follow the identical instructions. apt-get is a pretty common tool now. And get a Hello World program working. I'll put it up as an assignment. So in the end, I want you to submit a screenshot of Hello World working. What we'll do on Thursday is we're going to write quickly a class in Java, like we'll do a dice roller or something like that, a relatively simple class, remind yourselves about constructors and methods and that kind of stuff. And then what we're going to do is we're going to write the identical class in C++. See what's the same, see what's different. You'll kind of see this lineage at work, right? You'll see that, oh, C++ looks a lot like Java, but there's some nuance. Make sense? All right, questions, comments, concerns, bribes. Go ahead.
I'm just kind of wondering within the command line how you get back and forth so quickly from this screen to where you were writing the
Oh,
You swipe. No.
this guy? Yeah, so this is not a separate application that's running another window. It's actually a text editor running in DOS. So the name of the program is VI, and I'm editing hello.java. So I type in the command, and what you're probably questioning is I'm pressing the up arrow here to flip through past commands. You could also type in history and see your recent stuff. And I see what I wanted is number 100. So I could say bang 100, and that'll open it as well.
We'll see how long. It's added 2020.
Press escape,
But I think it'll be
then colon, WQ, right quick. Some of you might prefer to use Nano as your text editor. Nano's a little friendlier. So with Nano, they tell you how to get around in here. So if you want to save something, you hit Control O. If you want to exit, you hit Control X. What's up?
Where do we submit our assignment?
It'll be on Blackboard.
Okay.
So it'll be up in the next 2 hours, and then I'll send out an email to the whole class.
Okay.
But you get to Blackboard by going to my.cuw.edu and log in, and there'll be a link for Blackboard in there. Yep.
also, I'm looking at, well, I'm taking 18 credits out. I did the math for the amount of